in this video what we're going to do is just have a little extension lesson on how you could use redox oxidation states to balance chemical equations when you haven't got all the information provided. So if I produced this equation up here and said balance it, you would often look at me and go, well, where's the oxygens going, what do I do? So what we're going to do is see how we could use redox oxidation states to balance it. So the first job is to work out the oxidation state of each species, each element within those formulas. So the first thing to spot is that the Mn is going from +7 to +2, it's going -5, and that the Br is going from -1 to 0, it's going +1. Now these have to balance like on a seesaw, so we've got -5 on one side, but only +1 on the other. How many +1s do you need to balance a -5? Well, you're going to need to times it by 5. So that is our first thing. We're going to put a 5 in there, which would actually give us a 2.5 Br2s. Now, if you don't like that, you could double everybody now and go for 2, 10, 2, 5, but you would have to double everybody. Okay, so we've got that point now, we know what the balancing is there, and now we're just going to use our rule. So we're going to balance everything else by adding water and acid. So we leave a little gap because we don't know which side we're going to add the water and the acid to. So if we look at it, the elements undergoing oxidation and reduction should be balanced. Now there are 4 oxygens on the left, so I'm going to add 4 waters to the right, which means I'm going to add 8 H pluses to the left. And the last little check is to check the charges, and if you've done this right, you've not needed to take it apart into half equations, and it should balance now for charge, and you shouldn't need any electrons because otherwise you've done it wrong. There are 8 pluses, take away 5 is 3, take away 1 is 2, and there's 2 plus on the other side. Let's have another go. First thing to do is to assign oxidation states. So elements are always 0. In this, each oxygen is -2, so the N would be +5. So I've got 3 lots of -2 and it equals -1. Copper is +2. Here the oxygen is -2 and the nitrogen is +2. So if we have a look, our nitrogen is going down 3 and our copper is going up 2. We have to make these balance. Remember that our little thing, we need the +2s and the -3s to balance. How do we get that to stay level? We have to have 2 of these for every 3 of these. So I need to put a 3 in front of the copper things and a 2 in front of the nitrogen things, and then I'm going to use the rules. So everything else now . So what do I do next? I'm going to add some water to make the oxygens the same. 6 oxygens on the left and 2 on the right. So I'm going to give me 4 on the right. More to give me 6 on each side. And then add the acids to balance that out. I've got 8 H pluses because there's 4 times 2 H's on the right. And then check the charges. I've got 8 pluses and 2 minuses on the left, that's 6 in total plus, and I've got 2 times 3, which is 6 plus on the right. I have managed to write a full combined redox equation without breaking it apart. Now this is extension because you can go back to half equations at A level, and that is the standard method. So this is an extension activity just for those of you that want to look at how somebody might do this beyond A level. Let's have a look at the next one. Our manganate is +7. Each oxygen is -2 and there's 4 of those, which is where we get the +7 from. And in here, if each hydrogen is +1, the sulphur is -2. Here the Mn is +2 and here the sulphur is an element, so 0. So our sulphur has gone up 2 and our Mn has gone down 5. So how do we balance our scales? We would need 2 of these for every once I've got that, we follow the rules. So I'm going to add 2 lots of 4 is 8. I'm going to add 8 waters, and 8 lots of 2 is 16, but I've already got 10 in the 5H2S, so I'm going to add 6 more. And I'm going to check the charges. I've got 2 minuses and 6 pluses. That gives me 4 positives on the left, and 2 times 2 pluses is 4 positives on the right. So let's have a go at one more. If you want to practice this more, there are some in your maths workbook, and your teacher can provide you with further examples. There's one more. So in this one, we've got zinc going from 0 to +2, and the nitrogen, each of these oxygens is -2, so the nitrogen's +5, and then in here, it must be -3, because the hydrogens are +1, there's 4 of them. Yeah. So we've got to get to +1, I'm just going to rub those out because the hydrogens aren't important at this point. I'm just going to see what we've got. So 0, adding 2, 5, take away. Not take away 2, because it's not +3, is it? Don't fall into that trap. It's take away, we're going from +5 to -3. That is -8. So in order to make these balance, we're going to need +8. So 4 zincs and a nitrate ion. It's going to give me 4 Zn2+ and an ammonium ion. And then I'm going to add some water to balance the oxygen. I'm going to check the hydrogens quite carefully this time because I've got 4 in the ammonium and 6 in the water, so I need 10, and then 10 take away 1 is 9, 4 times 2 zinc, 2 pluses is 8, plus the ammonium is 9, I've done it. So you could have a go at 5 and 6, I will put the answers up in a second, so pause the video, have a go at 5 and 6. If you want more of these, you could ask your teacher. So that next example is a little bit trickier because the C's in the C2O42- were going up 1, but there was 2 C's. So you actually have that, it's really like a +2, not a +1. And so to balance that, you're going to need to multiply by 2 and 5. And then you also need to take account of that 1 C2O4 would make 2 CO2s itself normally. So that was a little bit trickier. Have a look at that. You could always talk to your teacher if you want them to explain that to you slowly. Let's have a go at the last one. Okay, and the last one there, the iodine is going up 1, and the sulphur's going down 8, so we need 8 iodines for every sulphur. Now 8 I's would give me 4 I2, so just need to be careful with that. And then on this one, the water's fine, but just be careful with the hydrogens, because although there are 10 on the right hand side, there are already 8 in the HI, so you only needed 2 more. So that's a little extension lesson there. That's not normal practice at A level to use that method, but you might find it handy when you're trying to check your balanced equations. Make sure that you're balancing by redox as well as by atoms.